In this video, you will learn about the classification of matter. But first, I just want to talk about what chemistry is and why chemistry is important. So chemistry is the study of matter, right, and the changes it undergoes. So matter, as we'll learn, is anything that has mass and takes up space. So studying the components of that is interesting in itself, but what we really care about is when matter starts to change, when we see the chemical reactions. Okay, so why is chemistry important? Well, as you can see from this diagram, that chemistry is here in the middle, right? It is known as the central science because all other science fields, biology, geology, astronomy, physics, right, biochemistry, they all require, right, a good understanding of chemistry, right, because chemistry is the study of matter. And everything we're dealing with on Earth has to do with matter, right, or energy. But if you have a good foundation in chemistry, that is going to ensure that you're going to do well in any other field of science. So please take this class seriously, and I hope you enjoy it because it'll give you a good foundation for your future classes. Okay, so like we said, matter is anything that occupies space and has mass. So we could put a picture of anything here. These are my two dogs, Trout and Summit, right? They have mass, they take up space, therefore they are matter, okay? The only other, I guess, if it's not matter, the only other thing it could be would be energy. Right? And we'll also discuss that later in this chapter. Okay, so the composition of matter. So matter is going to be divided into two categories. Pure substances, right, over here. Oops, over here. And it says this cannot be separated by physical means. And so physically means to, physically separate them by, filtering or a distillation, right? Whereas mixtures can be separated by physical means. So a good example of maybe a very simple mixture would be like sand and water. And you know that you can separate the sand particles from the water particles by filtering, okay? But for pure substances, this cannot happen. So let's start with the pure substances. Pure substances have a uniform or same chemical composition throughout. Okay, so here we are, pure substances. So that means when you look at it, it's going to look the same. So it could either be, right, an element, right? So a pure element, like if you were looking at pure gold, right, that would be a pure substance. And it says here we cannot separate by chemical means, meaning gold atoms cannot be separated into anything simpler, right? Gold atoms is the basic building block. Or you can be a compound, and this can be separated though by chemical means. Right? So an example of a compound like table salt, sodium chloride, right? That is made up of two elements, so we can separate them. It's not easy, but we would have to perform a chemical reaction, right, to separate the sodium and the chloride from the salt. Okay, so let's look at these two in more detail. Okay, an element, so pure substances can either be an element or a compound. Elements are composed of one type of atom. So over here you are looking at copper, okay? And it is only composed of copper atoms. So if you zoom in onto the structure, all you would find is copper atoms. And that can't be broken down any further, right? Otherwise you would start separating it into the subatomic particles. And a compound is composed of two or more elements combined in a definite ratio. Okay, so example here is water. You have hydrogen, H2O, and the definite ratio is 2 hydrogens for every 1 oxygen. And this can be separated by chemical means. So if we took water, right, and you run electricity through it or some other type of energy, right, you could separate it into its elements, hydrogen gas and oxygen gas. And we would need to balance that. Okay. But this is a chemical reaction, and this requires energy to do that. But a compound can be separated by chemical means, by a chemical reaction. Elements, where would you find them? Well, any element on the periodic table. Okay. So here's a periodic table, and you can see that we could have pure, where's gold? Gold, right? Copper, that's what we talked about. Iron, where's iron's there, right? We could also have oxygen gas or hydrogen gas, and those are elements. So anything here on the periodic table. Okay, sorry, going back real quick. The periodic table is organized into categories of elements. And you can see the colors here, that this zigzag line down the middle, boom, 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 the staircase separates the non-metals up in this corner with the metals. Okay, so we know like iron and zinc, right? Calcium, these are all metals. They're on this side of the table. The non-metals like carbon, diamonds, and coal, and oxygen gas, neon gas, these are all non-metals. And if you're found on the staircase, you have properties of each. And so these are called the metalloids. Right? You have some properties of metals, some properties of non-metals. Hydrogen is, even though it's placed over here, it has the properties of the non-metal. All right, so in the beginning of this course, you're just learning about some basic characteristics of atoms, classification of matter, right? Just periodic table, just some very introductory concepts. So some basic characteristics of the metals versus the non-metals. And these are things that are pretty obvious, but let's point them out. So here's a metal, and on a fresh surface, they will be lustrous. Right? They will have a luster. Malleable means that they are able to be shaped, right, into coins, into jewelry. They're malleable. And they are good conductors, right, of electricity and also of heat. Okay, that's why like copper wires are used to conduct electricity. Versus the non-metals, if they're solids, they're going to have a dull surface. This is sulfur here. They would be brittle. Right? They're not malleable. They're not able to be formed very well, shaped. And they are poor conductors of electricity, right, and heat. All right, so let's do a little practice here. We're looking at this element, and we see that it doesn't look like a metal, kind of looks like toothpaste, right? So we would classify this as a non-metal, right? That is white phosphorus. Right, number 2, you can see that it's lustrous. It looks like a ball of aluminum foil, right? That is a metal. Number 3, again, you can see the luster, and this is copper, right? So that's a metal. And number 4, that is a diamond, right? That is pure carbon, right? And that's a non-metal. One other point about compounds, like we mentioned sodium chloride, that is a compound or a pure substance. If you zoom into the salt crystals, you would see that there's a regular pattern for every one sodium, there's one chloride ion. And as a compound, sodium chloride, it's very safe. We eat it, okay? And it causes no harm. But if you were to separate it into its pure elements, okay, so sodium metal over here, and chlorine, that will come as 2 as a gas. They're both very hazardous, right? So sodium metal, you can see here is, looks metallic, but it's very soft. It's actually, you can cut it like toothpaste. And when it's so reactive that just in the air, it will react with water. So if you threw a chunk of sodium into water, it would explode. And chlorine on its own as a pure element, right, chlorine gas, right, is a poison, and that is very toxic. Okay, so both of them by themselves as pure elements, pure sodium and pure chlorine, right, are both extremely hazardous. But together, when they make a compound, right, sodium chloride, right, it's very non-hazardous. It has very unique properties as a compound. Right, the next category, right, so remember matter was separated into pure substances and mixtures. Okay, so we'll go on to a mixture. So a mixture is a combination of two or more elements or compounds. And mixtures can be separated by physical processes, by physical means. And mixtures are again separated into two categories. We have the homogeneous mixtures or heterogeneous mixtures. Homogeneous looks the same throughout, right? So it kind of looks like a pure substance, but it's not. And heterogeneous, you can actually see the different parts of the mixture, so the composition is not uniform. Okay, so homogeneous mixtures. The composition is uniform throughout. So if you look here, like at this cup of coffee, right? You look at coffee and you say, okay, it looks like a transparent brown liquid, right? It looks like the same substance throughout, but indeed, there's a lot of chemicals in there. There's water molecules, there's caffeine molecules, there's other components that are in this mixture. Okay, so this is what we call a homogeneous mixture. It looks the same throughout. Another example would be an alloy like gold, right? You could have pure gold, which is 24 karat gold, right? For every 24 atoms of gold, 24 are gold atoms, right? That's what's called 24 karat gold. This one would actually not be a mixture, but instead, right, a pure substance, right, as an element. But if we had a mixture with other atoms, like copper and silver, right, this is 18 karat gold, now it's a mixture of gold, copper, and silver. Okay? Even though when you look at it, it looks mostly gold and you couldn't really see the copper and silver atoms, right? So it's considered a homogeneous mixture, right? In 14 karat gold. 14 out of your 24 atoms are gold atoms. Okay? So you have even more copper and silver, but again, you can't see them separately. Okay. Heterogeneous mixtures. Now these, you will see the different components of the mixture. So it's not uniform. And so here's an example. Looks like Italian salad dressing, and you can see the different spices, right, in the dressing. Here is a chunk of cement, and you can see the different types of rocks, right, and gravel. And here's an example of iron, just iron bits and sand, and that's also a mixture, and you can see the two components. So the different parts of the mixture are visible. That's called a heterogeneous mixture. Okay, so remember, mixtures can be separated, right, by physical means. So some examples of separations are distillations. Okay, so this is how you get distilled water. So you can take regular tap water, you boil off the water, you let it come down here and cool, and what you should get out here, right, is pure, right, H2O, right? And what you would leave behind, right, are ions that were in the water, such as like magnesium, calcium. You know, you get calcium buildup at home. There's other components in tap water. but you can separate it by boiling off, physically separating the water from the other ions. Filtration, right? So again, if you had tap water in the filter, usually a carbon filter, this would pick up some of the ions right in there and leave you with H2O. Okay. And this is just another simple example of the removing the iron from the sand. Right? You could use a magnet. You can get creative and find a way to separate your mixtures. Okay. All right, so as a review, here's the classification of matter. Okay, so here's all matter. It can be separated into pure substances or mixtures. Mixtures can be separated by physical means. Pure substances cannot. Pure substances are then separated into elements and compounds. Compounds can be separated, right, into elements, right, by chemical reactions, but elements cannot be broken down any further. Okay, mixtures. Mixtures, you can have two types. If they look the same throughout, right, it's homogeneous. If you can see the different parts, it's heterogeneous. Okay, so let's just do a little bit of practice. So classify as an element, compound, homogeneous mixture, or heterogeneous mixture. Okay, so apple juice, right? I'll just do, you can pause the video and answer these and then come back. Apple juice is homogeneous. Steel, that is an alloy, right? So again, that's a homogeneous mixture. Potting soil, well, you know, you can see the little parts, different parts in there. So that's a heterogeneous mixture. Zinc, right? That's an element, so a pure substance. Carbon tetrachloride, that's a compound, so another pure substance. Air, although you can't really see it, but you know that there's oxygen, carbon dioxide, argon, there's nitrogen, so that is a homogeneous mixture. Distilled water, right? That's pure H2O, right? So that's a compound. Spaghetti sauce, you can usually see the different bits, so that is a heterogeneous mixture. In titanium, that's an element. Okay, we'll stop here.